Okay, so part of 3.3 is linear inequalities, and that includes lines. It also includes absolute value. And these three word problems that we have at 3.3 is about productive struggle. So this video is about how do you get through these problems when you're not exactly sure what to do? And how do you brainstorm and figure out ways to work out problems when you're not sure what to do? So productive struggle is the name of the game here. And in Algebra 2, y'all have to figure out your capacity for that productive struggle. So let's look at these three problems. You were given these already. You were asked to go through them either by yourself or with a partner, depending on your particular class. And I'd like to start by, in this first problem, summer jobs, circling the things that we know. So, for example, we have 20 hours. At most 20 hours we're supposed to work. If this was a homework problem, you'd probably say work less than or equal to 20 hours. Like that would be how I would simplify that for my notes. You need to earn at least $92. So earn more than or equal to $92. So that's the second phrase that we have to cover your weekly expenses. You have two jobs. One's dog walking at $7.50 per hour. So I'm going to earn this through either dog walking at $7.50 per hour or car wash. Car wash, $6 per hour. And those are how I would take notes to figure this out. So then you have to decide, okay, I've got a graph here. I'm supposed to graph this. I'm supposed to graph it, and I'm supposed to shade the inequality because these are both inequality ideas. And how do I do that? So first you have to choose. Just because I've written in this order, that's how they came out here. I'm going to write dog walk here. Dog walk. And these are the hours that I work. So I have to work dog walking hours less than or equal to 20 hours. And I also have to work car wash hours. So I'm going to write car wash hours here. And if you look, there's 20 tick marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hours, 20 hours, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hours, and 20 hours. So I could work 20 hours at each job. I could work a combination of the two jobs, just depending on how they schedule me or whatever. So I'm trying to figure out how I can work 20 hours or less and also make $92. These are two different scenarios that have to go together on the same graph. So the kind of productive struggle that I'm asking you to do is, how do you do this? Do you start with equations? Some people are really good at the equations make sense and they can write an equation. Are you somebody who's just going to think through things? So for example, when students were working these together the other day, they might have said, okay, well, if I have to work less than or equal to 20 hours, I could just work 20 hours at the car wash. I could work 20 dog walking hours. I could work 10 here and 10 there. I could work anything in between that in order to get the number of hours I need. So this line that connects these dots represents if I work 19 hours car wash, but 1 hour here for dog walking. And I could do this all the way down. So I'm just going to connect these dots in a line, and that represents the number of hours. It turns out that I'm going to look for, less than 20 hours. So 20 hours or less goes that way. I'm just going to do that for now so I don't mess up my graph. And any value inside of this triangle works. So I could pick this point. That would be 1, 2, 3, 4, 5, 6, 7 plus 3. That would be 10 hours. And that is less than 20 hours, and that works. And I could test a bunch of these in here. So in the productive struggle, you have to figure out what they've asked of you and how you can think about it on a graph. So maybe you wrote 20 plus 0 is less than or equal to 20. 0 plus 20 is less than or equal to 20. 18 plus 2 is less than or equal to 20. Like, you may have thought through some scenarios where this was dog walk and this was car wash, and that makes sense to you. And after you plug in some things and make sense out of the context of the problem, then you can go, well, if this one is X and this one is Y, then X plus Y has to be less than or equal to 20. And that gives you an actual equation that you could graph. And that will correspond with this line that we drew. But in the way I've talked about this problem right now, it was not about the equation. It was about just like what makes up 20 hours and how that makes sense. Now, if I worked 20 hours at the car wash, and car wash was $6 an hour, so if this is 20 hours times $6, I'm going to make $120 here. $120, and that's too much. So I need to figure out how I can make $92. Because this value is fine. It satisfies the requirement, but how could I work less than 20 hours and still make $92? So at that point, I grab my calculator and I say, all right, calculator, I have to make $92. I'm going to make $6 an hour. So I have to work 15.33 up here. That's 10, 11, 12, 13, 14, 15.33. That's about there. 0.33 hours to make $92. Okay, so I'm starting to see how hours and hours make sense on my chart. It's not dollars I'm looking for. It's how many hours times 6 makes $92. And how many hours times 750 makes $92. So now I'm going to do the same thing. 92 divided by 7.5. That gives me 12.2. So that's 10, 11, 12.2. So what I see now is that if I connect those 2 points, then this represents $92 exactly. And I'm trying to make more than that. So I'm going to try to make more than $92. More is up. So I'm going to go that way. So what should happen is that if I had a pencil, I would shade it in nicely, right? This would be all of this area here. And I could pick any point. Let's pick this point. That point is 12 and 3. So that's 12 times 750, because it's 12 this way, which is 750, and then plus 3 that way, plus 3 is $6. I'm going to check that on my calculator. 12 times 750 plus 18, 3 times 6, and that's $108. So I only worked 15 hours, but made $108. So that point right here works. And I could do that for any point that's in that range. And so I need that other equation. How did I check this? Well, I said hours times 750 plus hours times 6, and I got a value. So my other equation is going to be X is the 750. 750 times X hours plus $6 times Y hours equals, it's supposed to be greater than 92. So greater than or equal to $92. And now I have another equation. So I can say I've got an algebraic way of describing the situation, and now I can see a picture of all the values at work. I can see right away that dog walking, logically that makes sense, but I can see right away that dog walking is the one that has fewer hours, like visually I can see it. And so this makes me $92 for the least amount of hours. And then I could check my other extreme points here to see which one makes me the most money. It's going to be this value. So anywhere in this range right here of dog walking hours, 12 plus an hour the other way, anything this way is going to make me the most money. So in the productive struggle, you're reading, you're thinking about it, you're coming up with possibilities, and that helps you to draw your conclusions and write your algebraic equation. The second one here says we've got a prom committee, and there's a lot of things that have to happen. We have to have 5 to 8 representatives. They're in the junior class and the senior class. It tells me X is the number of juniors, so X is juniors. That leaves Y to be number of seniors. And so right away in this problem, students did a number of things. Some of them went ahead and wrote out this 5 to 8 in a way that makes sense. So like a 5 is less than students. I'm going to write students because I don't know if they're juniors or seniors. It's less than 8. Less than or equal to 8. At least 2 juniors. So that means juniors is going to be greater than or equal to 2. Same thing with seniors. If we have to have 2 of them, we can only have 8 people. That means that juniors is also less than or equal to 6, because 2 plus 6 would be 8 people if we had 2 seniors. And so this also goes for seniors. So in working this problem, some students went straight to writing out the words into mathematical symbols. And we could take this further and say X is junior, so X is greater than or equal to 2. X is less than or equal to 6. And we could graph that. I'm going to do that in a minute. But I also had students who just started with the graph. And they said, okay, well, if I have 1 junior and 0 seniors, I'm right here. That does not work. That's an X. If I have 2 juniors, that's good, but that's still just 2 people. That's not enough. So I need to go up, right? I need to have at least 2 juniors and 2 seniors. I'm going to start here. Is that value a value? Well, 2 plus 2 is 4, and I need to have 5 students. So this one doesn't work. So another entirely good way to work this problem is to just try some numbers. Make a chart and see what works. Let's do the math though, because at the end we do have to figure out the math, and I don't want this video to be too long. So let's say that I have at least 2 juniors. X is going to be 2, that's this line, or more. It's going to go in this direction. I also have 6, so 3, 4, 5, 6 here. There we go. That's juniors. Seniors has the same rules, so there's at least 2 seniors, and there's at least 6 seniors. Less than 6. 1, 2, 3, 4, 5, 6. And what that gives me is, hey, it's probably in this square. But I've already discovered that this X didn't work, so this corner didn't work. I could check this corner and see if it works. That would be 2 juniors plus 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this does work. That would be 8 people. That one works. Let's check this one. That would be 6 seniors and 6 juniors. Okay, that does not work, right? You could test each quantity of juniors and seniors to see what works. But we have this notation. The students, the number of students, juniors and seniors, so this could be X plus Y, has to be bigger than 5 and less than 8. How do we put that into an equation? And this is the tricky one because this has 2 different ideas in it. It has to be both bigger than 5 and less than 8. And what happens when you go to graph this is you have to consider them separately. So you need to say that 5 is less than or equal to X plus Y, juniors plus seniors. And also, X plus Y has to be less than or equal to 8. And these are 2 separate lines. So that's the tricky part of this one. And you would figure that out if you went and added them up. You would end up with 3 plus 5, 4 plus 4, 5 plus 3, and 6 plus 2. Those numbers all work. And when we graph this, it ends up looking like